Welcome you all in this new video, and in this video we are going to discuss how a body is reacting when it is rolling from an inclined plane. Okay, so this is the topic of our lecture. Okay, so understand what is this statement saying: a body is rolling down in an inclined plane. Okay, and you have seen in many times that this is like inclined plane which have some angle from a flat surface. Okay, we can say that is an inclined plane. Okay, so this is your inclined plane. A body is rolling like this from here, not sliding but rolling. Okay, so in this video we will try to find how the acceleration of that body will be counted. Okay, so let's start our video. So I hope you are clear with the topic what it is. It is regarding a body is rolling from an inclined plane. Inclined plane means that have some slope like this. Okay, and there is an angle this, and this angle also plays a very important role in deciding how much intensity of that acceleration will have. Okay, so let's start our video. So first of all, let's understand this through an example, or sorry, through a picture. So this is your flat surface, and this is your inclined surface. Okay, so this is your inclined face. Let's suppose there is a circle, or there is a sphere. Okay, let's sphere have radius r. Okay, this sphere is placed at a point, let's say P. Okay, and we assume that this is moving with some velocity. Let's say this is moving with velocity v. Okay, understand guys one thing, this is not sliding. Sliding means this is like going with a one direction or with one portion. No, it is rolling like this. Okay, when it is coming down toward this point, let's say it is O. Okay, so at point P we are assuming that this spherical body, okay, moving with velocity v and reaches at particular time. Let's say it take time t, okay, to reach at this point. This is a Q point. Okay, so now body is here. Okay, so this from P to Q, the distance, that is a linear distance. Okay, so we know that. So now we have to understand what is the vertical distance, how much height it has come down. Okay, from point P to Q. So this is your this P, and let's say this is S. The distance between P and S, that is the vertical distance that this sphere has traveled. Okay, so now understand this inclination angle. Let's suppose that this is your slope, and slope make an angle theta with the flat surface. Okay, so if this is theta, and this will be also theta. Okay, now by applying the Pythagoras theorem, you already know. Okay, and from triangle PQS, okay, from here if we calculate sine theta, what will be your sine theta? That will be PS over PQ. Okay, so let's suppose that distance between P and Q is S. Sorry, it will be confusing, so let's change the name for this distance. Okay, yeah, let's suppose that this distance is x. Okay, and we are deriving, so PS will be equal to PQ sine theta, and we know that what is the value of PQ, that is x sine theta. Okay, now we easily come to know that what is the distance, okay, that traveled by the particle, by the sphere, to reach from point P to S parallel, means it traveled a vertical distance of x sine theta. Okay, now this is about how much distance it traveled from vertical distance. Okay, means how much height has been decreased when the particle, or when this sphere comes from point P to point Q. Okay, so this we come to know about it. Okay, now we have to understand how we can calculate, or how we can derive the relation for acceleration of this. How much we come to know that what is the acceleration of this body, okay, this spherical body. So for that we have to understand, whenever a body is traveling from a particular height, okay, So what does it mean? It means that its potential energy is decreasing, okay, because we know that potential energy is equal to mgh, okay, where h is the height, and if you know that potential energy is directly proportional to height. As the height will decrease, it means that body is going toward the surface, okay. It means that height is decreasing. When height is decreasing and potential energy is also decreasing, and that energy, whatever potential energy is decreasing, with the same extent your kinetic energy will increase. So concept is very simple. It means that our potential energy decrease will be equal to increase in the kinetic energy. So this is the our basic phenomena, okay. So we can say on the basis of this principle we can easily derive the acceleration formula, okay. So let's go further. I said the potential energy is equal to kinetic energy. Let's draw that diagram again, so it will easy for us to understand completely, okay. So this was our p, q, s, and this distance was x sine theta, and this distance was x. Here was the body, and here is after some time t, okay. So this is the scenario, okay. Now we have to understand what is the kinetic energy of this particle. Now understand guys, it has dual motion together, okay. Dual motion means it is also in translation motion and also in revolution motion, means it is rotating and it is sliding also, means translation and rotational motion. So kinetic energy for rotational motion is 1 over 2 I omega square, and for the translation motion that is 1 over 2 mv square. M is the mass of this sphere, okay. So now you are confusing that what is this I. This is the moment of inertia. Moment of inertia is the property of any body, okay, which prevent it from changing its position, changing its state. It will be in motion, it will be in static state, okay, whatever it will be. So we know that what is the moment of inertia. Moment of inertia is mass into square of the radius of gyration. What is the k? K is the radius of gyration, okay. You have to understand it. Radius of gyration means the distance from that center of mass. You know that every body has a center of mass, okay, and the distance from that center of mass, okay, to the average outer particle, okay, in average distance we can say, okay, from the average distance from that axis, okay, means from that center of mass, okay. So the distance between that is called k. K means radius of gyration, okay. Gyration, you have to understand it. So now place this value here. So our kinetic energy will become equal to what? 1 over 2 I, okay, sorry, it's I is equal to what? M k square omega square plus 1 over 2 mv square. So this is the kinetic energy. Now we know that v is equal to omega r, okay. So omega is equal to v square over r, okay, sorry, it's about v over r, okay. Now place the value of omega in this expression. You will get 1 over 2 m k square v square r square, okay, plus 1 over 2 mv square. So this is the kinetic energy. Now equate this all expression, okay, equal to potential energy. So what will be in the next point? That will be potential energy is what? Potential energy is mgh. We know that. What is this h? H is the height that is traveled by that body, okay, toward the ground, okay, means the decrease in height, we can say it, okay. So what is the decrease in height? That is x sine theta. Let me draw that again, so it will help you to understand that easily, okay. So this is the h. H means height. So and what is it? It is equal to x sine theta. You can remind that in previous, okay, step we did this thing like this. This is the vertical distance, okay, and it means that this is the distance or height that is traveled by that body, okay, toward the ground surface, okay. It means that what height has been decreased, in which amount? That is h. Okay, so you can place that is equal to kinetic energy. We know that we have already the expression for kinetic energy, mgh is equal to 1 over 2 mk square r square over, sorry, v square over r square plus 1 over 2 mv square. Okay, when we will do this thing further, so we will get the value of what, v square, that is v square I am taking directly here. You can do this thing very elaborately. Okay, so this will be 2, okay, r square over r square plus k square. Okay, and it is g sine theta. Okay, I had just placed the value, so I can write it mg x sine theta. Okay, now you can understand, we had easily derived this thing from we can say here is x. Okay, so now placing this value, okay, we know that what is the value of v square that we have got. Okay, that is 2 r over r square over k square plus r square g sine theta x. Okay, now placing this value in the expression that we already know, that v square is equal to u square plus 2a s. S is what? S is the distance that is traveled, and here is the distance x. So you have to, v square is equal to 2a x equal to, means now we are placing the value of v square here. Okay, so don't be confused. 2 r square over k square plus r square g sine theta x. X to x cancel, 2 to cancel, so we got acceleration is equal to r square over k square plus r square g sine theta. Now understand the beauty of this acceleration, guys. This is equal to r square over r square plus k square and g sine theta. Understand, guys, by knowing the angle of inclination, okay, this theta, you can easily determine this acceleration value. Okay, because you have to understand also the radius of that sphere. Okay, and what is the k? By knowing the value of k, you can also easily determine the, k is radius of gyration, and you can also derive